SAYAN PRAMANIK is an architect, academic, and researcher with over 8 years of experience in architectural education and urban studies. He currently serves as an assistant professor, with teaching and research interests spanning urban morphology, spatial analysis, and the sociocultural dimensions of the built environment.
His work engages critically with theories of space, movement, and urban form, integrating computational and analytical methods with architectural and planning research. He is actively involved in academic publishing and peer review, and his scholarship emphasizes methodological rigor, interdisciplinary inquiry, and socially grounded urban research. He is presently pursuing advanced doctoral research with the aim of contributing to globally relevant discourse at the intersection of architecture, urban analytics, and spatial justice.
Hello, good afternoon all. I think my session will be more interesting for the students. So this is straight away to the points which I guess what we are looking forward to, because everyone trying to talk and bring about heritage and the changes. I think we were also having a post-lunch discussion with sir that how can we bring technology into heritage conservation. So I wanted to talk about certain steps that I have taken so far, some of the things that I successfully concluded, some which I'm still working on. So basically I will talk about digital heritages. So I hope you know that this has been since morning, everyone is saying that India is a land of heritage and we should think about heritage conservation and all those aspects. I am not going into much further details as how we take inspiration. I'm sure you all also invest yourself in deep into, let's say, theory of architecture or theory of design. So you get a lot of philosophies from different persons, right from Italo Calvino's to Spiro ideas. And even, I mean, Christopher Alexander, that's a very common name everyone knows about. And I think same goes for Kevin Lynch and his ideas about how we can think about visibility and visibilities as philosophy, and from philosophy to the calculation of visibilities and all those aspects. Other than Kevin Lynch, I think Patrick Geddes, Gordon Cullen, Lewis Mumford, Bill Hillier for space syntax, they all have tried to quantify the philosophical aspects or the qualitative aspects in architecture. So the major turnover or turnout about how we can quantify different qualitative aspects in architecture, what we call as intangible aspects, and to bring them into tangibility. So I think there are quantitative aspects which, by so far are based on ray optics, visibility analysis, urban imagery scoring. I'll go through certain software tools that are readily available. Some of them are already used as some softwares, some tools. Some are APIs, some are kits. I'll also try to bring AI/ML and I'll make you understand how AI/ML works these days. So maybe the quality, when we talk about these days, the researches which are going on in international forums are mostly into perception, cognition, wayfinding, safety, security, and all those other aspects. So that is a little more intangible, like the very similar aspects of comfort that nowadays people are trying to perceive through different quantitative aspects. So comfort is something they are working on. These are some visibility analysis research papers, and that you can always go and search on Google and you can find it. So, you know, we had since history been mentioned about different sites, the precincts. I think in the morning ma'am was talking about roots. So roots being an important aspect of how we should understand the importance of a precinct. So even in those aspects of precinct analysis, I have worked a little on it. So that kind of spans to the aspect of urban morphology as on a city scale, or maybe we can talk about the urban fabric scale as well. So I will come straight away into two aspects of this digital heritage understanding. The first at the building level. So I hope you nowadays know about LIDAR as a technology, and many of you have tried to understand and measure different buildings in terms of using LIDAR. So LIDAR gives us a very accurate data analysis, as in those accurate data analysis has point cloud data, and those point cloud data are having coordinates. So far, so now we have only understood up till this part, but are we venturing further from this particular point? So that is whether are we using objects or OBJ formats or GLTA formats, which is GL transmission formats, and then GLB or binary GLTA formats. So these formats are going to help you understand when we are talking about something in the relationship of digital twins. I hope some of you have heard this term called as digital twins nowadays. So when we talk about digital twins, on an international scale, people have tried to talk about, hello, yeah, on an international scale, I think digital twins are something that people have tried to talk about how that can work towards preservation, conservation, development on multiple levels of understanding a city and its dynamics. So there are other formats like STL formats. Point clouds are most commonly used these days, and then there are all data which are captured, and then that can be utilized for multiple aspects. So yeah, so there are then DAE, or that is in the KOLKATA format, and then there is this Filmbox and other PD3.in formats as well. So these all different formats are used for different purposes. Some of the purpose and some of the objects that had already been utilized when I was trying to explain how different objects can be digitized. So these are few examples. This is Keshav Narayan temple. I used my mobile to do the LiDAR scanning, and I thought like how further we can go about digitization as a tool, and then how further it can help us create different digital twins. So when we are talking about digital twins nowadays, you people are also aware that now 3D printing technology has come up. So people are trying to create 3D printed conservation techniques as well, where they are trying to implement those restoration aspects through 3D printed materials. That is not happening in India, but outside India, they have already started doing it. So these are few examples with different formats, and this gives us a very accurate geometry, and let us understand what exactly was the intent for it. So using this LiDAR technology, additionally, you can create a wire mesh frame. So this wire mesh frame, whenever we are talking about, it helps us understand how exactly, or wire frame that helps us understand how exactly where the facade or the fabric or the lamina of that surface was. So where the wear-ins and tears have happened, it can be identified to analyze structural details, the derogation, the weathering, or there had been a tampering physically that had been done to that particular surface, or any other aspects into it. So the next part of this LiDAR generated data, what I try to do is try to understand how imageries, or using imageries, how machine learning data can be used. So this was an experimentation that I used in one of my studio classes. So what we tried to intend was to generate by machine learning algorithms using MLs, how we can generate different style of architecture. For example, if I say that this is a colonial building or Victorian era's building, so how exactly machine understands that it's a Victorian era's building, and it will give us exactly a Victorian era's building elevation, or for that matter plan. So we did an image training, and that from that image training aspect, we generated such kind of images after giving them an exact understanding of the detail of certain architectural features, characters, and how then it trains and give us certain output data. So these are generated from image training machine learning algorithms. Then comes another aspect, which I think many of you already know, are J-graphs or justified graphs. These J-graphs or justified graphs mostly try to understand the social logic of space, which is how different logic were implemented to understand different spaces. So sequence of spaces and their connections and their correlationships was identified through a proper quantitative method. So and then there had been more codes to it. Like this is one tool which is called as morphocode. So in morphocode, you can explore how different morphological codings can be done, and there are different aspects like land use, development intensity, demographics, etc., that can give you further details of all these ideas of I forgot the figure ground as well. So that will give you the idea of how exactly all the data sets that can help us create some analytics into it, that this kind of tools help us. So these are some figure ground analysis that are already there, just been done by morphocode. Yeah. So coming back to the point which I was mentioning about J-graphs. So J-graphs which help us understand the I think nowadays we all know, being students of architecture, about zoning, about privacy, security, etc., etc. So this help us understand that level of interventions, level of access, distribution of spaces, their connectivity, interconnectedness, and so many other features. So by doing this is one experimentation that was done for old traditional houses of Middle Eastern countries. So one of our students, they tried to attempt like how exactly their spatial practices were, and to understand the culture of those spaces, and how in those spaces how exactly they were trying to develop certain activities. So activity-led spatial patterns that was observed and that was noted. There are these results which are in numbers. I'm not going into that detail. And yes, there are certain repositories which you can always access through, which can help you understand how this can be created. So this is about, again, a building level geotips data that you can create from point cloud data. These are some ready codes, some codes that you have to tweak to create a better detailed analogy of however buildings that you are taking. It can be of a smaller scale. The larger data sets will go into detail. It will go into more further detailed points. So these are also some codes. So now I'll come to the part which was about the large scale, large size or large scale data. When I talk about large scale data, I try to incorporate the Google metadata, which is for city level or maybe a neighborhood level. And talking about Google metadata, I try to incorporate it in Google Colab notebooks. Mostly people have done so far about all these things into Jupyter notebook. So that's also a Python language. I hope many of you are already acquainted nowadays with different languages. So using that Python language into Google Colab notebooks was one of my first attempts. Then I incorporated the GeoJSON data, because if you try to go into building data sets, which is let's say of Kolkata, of let's say JADAVPUR area, you will hardly find the detailed data in any other formats rather than GeoJSON. So you have to get the GeoJSON data sets, and then maybe you have to use TensorFlow or PyTorch to clear all the data and to have a distinctive data sets. From that, maybe you can use GSUTL as a command line, or maybe you can use some Python language. I use the collaborative notebooks. So from that, we used kind of CNNs, convolution neural networks, and GNNs. These CNNs and GNNs are kind of accurate segment different materials and features and images. And after that, we can denoise the autoencoders, which is the point cloud data. So I was talking about point cloud data at a building level. Now I'm talking at a point cloud data as a large size, city level data sets, right? So yeah, these are some of the preliminary data sets that we try to extract, and we try to create through some encoders, through the programming encodings, as to generate the building forms. And from the forms, it is also giving us different analysis. So some parts of Kolkata. And I hope you all know by now that space syntax is a very commonly used tool in terms of understanding the spatial analysis and different aspects of spatial analysis. So this particular tool helps us understand the network level analysis. So basically, if I distinguish two particular aspects, the first will be a network level analysis, the other will be a building level analysis, or the building footprint level analysis. So building footprint level analysis also might incorporate the building heights. So that is a part of morphological analysis, and the part which is a network level analysis that can be based on only the networks which are there. So space syntax helps us in the network level analysis. And then these are the OSM data. For large size, you will require GeoJSONs, as I just mentioned. And maybe then you have to use certain websites like Planet OSM, and you should know how to extract the data, because there are certain codes by which you can extract the data and can directly use into your codings, the programming. So in the morning, I think someone was mentioning about how social media can be helpful. Correct. So talking about exclusively about social media, these are like notes. So if you can see media map notes, which exclusively works as the social media data points. So what we can do is we can extract images which are taken at certain particular locations through maybe X, Meta, or any other social media platform, and we can understand how viability or vulnerability those sites are. Those sites then can be thought about, either restored or enhanced, or whatever policies that we can keep framing about. So that's how we are using social media data into our programming and conservation techniques of different parts of the city, right? So these are some of the codes. I mean, it's a big, huge, long code. So I'm just showing you part of it, and I'll be quick. So these are some of the data analysis that I've already got. I'm not going again into further details. So I think these are some international authors. I think many of you have already come across this. So they have tried to talk about how drive, bike, walk, or bike or walk, or drive, bike, walk in Kolkata. And that's the kind of analysis that can be generated within minutes. What I was more intended to make you understand that this, if you are learning, it will make you, I mean, it will take you some time to learn, but once you have learned it, it will hardly take some minutes to come into this data sets as in results. So I'll quickly go into the philosophy of what I was looking into, that is the spatial aspects, integrating the socio-cultural and analytical aspects, so creating a heritage evidence digital impact analysis. I'll not go into the methodology of it. So there is another tool which is as a street level imagery. ViewQ is the tool, and using that ViewQ as a tool, it gives you an understanding or view score of how those areas are. So we can say by just clicking an image, let's say I go into the roads, I click an image, and I can say whether it is good or bad, or qualitatively good or bad, and quantitatively good or bad. So it takes up different parameters, and these are the process by which that can be done. I tried to contact the professor who has developed ViewQ as a tool, and we have been working on it since on that. If you people are aware of it, there is another software which is G-Plan, which is also trying to incorporate as generative plan based on giving only sentences. I mean, let's say I need a 2 BHK house, so they will generate a 2 BHK house in allotment number of possibilities. Professor Shekhavat, working in BITS Pilani, is also trying to develop this G-Plan as a tool, and we are also working on that. So I'll be very quick about how human cognitive ability is challenged through AI, and we are trying to understand the relationship of culture and harmony and wayfindings. And these are some of the other tools, and this is one more analysis which talks about one of a small region, their data sets, their spatial analysis, their other data sets. So it talks about, I'll be very quick, that's why I just showed you the different data sets just to create an interest that how exactly different aspects which are quantitative can be incorporated to implement and analyze different spatial features. So yeah, so the basically idea is to create a place identity, or whenever we are talking in the morning about place belongingness, that belongingness and identity can only be created by understanding the quantitative aspects of it, and quantitative qualitative analysis should be done onto it. Thank you.